We're just constantly bombarded with information, right? So in a world that's so full of noise, how do you find the actual, meaningful signal? You know, that's a huge question, and it's really at the heart of discovery itself, whether we're looking up at the stars or maybe a little closer to home.
So our story kicks off right here, with this old piece of chart paper from back in 1967. A Cambridge graduate student, Jocelyn Bell, had a pretty thankless job. Tracked down all the random radio interference for a brand new telescope. But while she was sifting through literally miles of this data, basically static, she spotted something odd. A tiny little blip that just kept showing up.
And this is where it gets really interesting. Bell figured out a critical clue. The signal wasn't random at all. It kept reappearing based on something called sidereal time. Now that's just a way of saying time that's measured by the position of the stars, not our 24-hour clock. And that could only mean one thing. Whatever was making the signal, it wasn't on Earth. It was coming from deep space.
And get this, the signal was shockingly precise. It was pulsing every 1.337 seconds on the dot. I mean, the regularity was just unbelievable. It was so structured, so unlike anything they'd ever seen, that the team playfully nicknamed the source LGM1. Yep, for Little Green Men. For a minute, they had to wonder, was this a message? A beacon from someone else?
Well, the whole little green men theory didn't exactly last long, because pretty soon, Bell found 3 more of these signals, all coming from completely different parts of the sky. An interstellar network of aliens all signaling at once seemed, let's just say, highly improbable. They hadn't found extraterrestrial life, they'd stumbled upon an entirely new kind of star. What Bell and her supervisor, Tony Hewish, had actually discovered was the very first pulsar. The best way to picture it is like a cosmic lighthouse. You've got this super dense, spinning neutron star that's shooting out beams of radiation. And from our perspective here on Earth, we only see a pulse of light every time that beam sweeps past us. So what everyone else dismissed as noise was, in fact, a revolutionary cosmic signal. And this is a brilliant illustration of how discovery works, right? But it also brings up a really crucial question. We filter data to find stars, but what happens when the data is an entire culture, and the filter is our own way of seeing the world?
This very same process is at the heart of the work of philosopher V.Y. Mudimbe. He argued that the Western idea of Africa wasn't something that was simply discovered. Instead, he said, it was invented, constructed through a very specific and very powerful lens. Mudimbe called this lens the Western episteme. Now that sounds a little academic, but you can just think of it as a set of rules for what counts as knowledge. And this framework didn't just observe Africa, it actively organized and defined it based on Western values. And in that process, anything that didn't fit the rules, like indigenous traditions, well, that was just dismissed as meaningless noise.
The effect of this was profound. This constructed signal of what Africa was supposed to be became the accepted reality. It became so powerful, as Mudimbe notes, that it became the very foundation that even Africans had to engage with to define their own history and culture.
So how does this invention actually work in practice? Well, we can see a perfect example of it in the history of European art. Just look at the difference here. On the left, we have this engraving from 1511 showing Africans. But look at their bodies. They're posed in that classical European ideal called contrapposto, that sort of relaxed, S-curved stance you see in Greek statues. They are effectively blackened rights. Now compare that to Durer's portrait on the right, which feels like a direct observation of a real individual person.
See, that engraving wasn't an artistic failure, it was a success of its own underlying system. The powerful signal of the Western artistic norm just filtered out the noise of actual physical and cultural difference. It basically represented the other in the image of the same.
This kind of filtering can lead to some incredible controversies, where a powerful indigenous signal gets completely overwritten. A perfect example of this is the fascinating story of Dogon astronomy.
So, for centuries, the Dogon people of Mali have held this incredibly complex knowledge about the star Sirius. Their traditions describe an invisible companion star, a 50-year orbit, and its unbelievable density. These are details that Western astronomy only confirmed hundreds of years later, and only with the help of powerful telescopes.
This is just a stunning cultural anomaly. It raises a massive question. How did they know? How could they possibly possess knowledge that, for the West, was on the absolute frontier of science?
Well, the dominant Western signal offered a pretty simple explanation. The famed astronomer Carl Sagan hypothesized that a European visitor must have come to the Dogon in the early 20th century and just told them.
The assumption there is crystal clear. This knowledge couldn't have come from the Dogon themselves. It had to have come from the outside.
But there's a big problem with that idea. The indigenous signal was already there. The Dogon have a ritual called the Sigui, and it's based on this very astronomical cycle. We know it was performed in 1847, long before Western science could have possibly provided that information. The timing just doesn't add up.
So let's bring these two stories back together. On one hand, you've got a strange pulse from space, at first dismissed as noise, that's revealed to be a signal from a pulsar. On the other, you've got sophisticated indigenous knowledge, treated as an anomaly that gets reattributed to fit a Western narrative. Its own powerful signal gets dismissed.
And here's the crucial point. The search for a signal is never a neutral act. The frameworks we use to find meaning, whether there are scientific instruments or cultural assumptions, they don't just find reality. They actively help shape.
And that brings a whole question right back to us, doesn't it? It forces us to ask, what are the powerful signals that are shaping my own understanding of the world? And, maybe more importantly, what crucial information, what other realities might I be dismissing as just noise?